Hello, in this video we are going to look at the normal distribution, and this is for learning intention 51. Word of warning, the equation for this looks terrifying, and it is, but the thing is you never actually have to really use it. You have to know it exists and you just have to know it's kind of there, but you never use it. So I'm going to show you something that looks kind of scary, and then you're never going to use it. Alright, what is the normal distribution? Well, I'm just going to put in brackets Gaussian here, because I know I'm going to call it the Gaussian distribution as well. It's named after a mathematician named Gauss. These days people just call it the normal distribution. And I think there were some mathematicians before him, before Gauss, who were kind of onto it, but he was your leading he's called the Prince of Mathematics. He was the leading guy at the time, so Gauss got the credit, but I think it was someone else. So we're going to call it the normal distribution. If I call it the Gaussian distribution, I just mean the normal distribution. Okay, what is this thing? This is what it is. You can write down this formula once, and I'm pretty sure you'll never have to write it again. So f of x equals 1 on sigma, which is the standard deviation, square root of 2 pi, e as in the natural number, to the power of negative a half, x minus the mean over sigma, all squared. This is a probability density function that gives us the normal distribution. This thing here. You'll probably never have to write this equation again. What this is saying is, it's saying a few things. First of all, it's a PDF. It's a probability density function. So if you integrate this, it'll give you an area of 1. And it kind of looks something like this. When you're sketching this graph, we just sketch the x-axis because we don't even care about the y value. Remember, we're just caring about the area under the curve. So don't even bother doing the y-axis. It looks something like this. This is how your method scores in the state will be distributed. This is just what happens. It's a bell-shaped curve. That should be nice and smooth. There's no need for that little lump there. It's often called a bell-shaped distribution, a Gaussian distribution, a normal distribution. It's a probability density function. It goes from negative infinity, goes like that, then goes off to positive infinity. It's got asymptotes there and there. And the mean sits right here. That's the mean. And one standard deviation left and right of the mean. So one standard deviation. So if this is the mean minus a standard deviation, and this is the mean plus a standard deviation, that's about approximately 68% of your data. That's 68% there. So if you had a mean of 10 and a standard deviation of 2, 68% of the time you're going to get a value between 8 and 12. 68% of your data lies within this interval. Alright, so, and then within 2 standard deviations, so here's our bell-shaped curve. That's a shocking drawing. I'm going to redo that. Within 2 standard deviations, so if this is your mean, let's do 2 standard deviations. That's about 95% of your data. So mu minus 2 sigma, mu plus 2 sigma, that's 95% of the area under the curve as well. So there's a 0.95 chance that this continuous random variable will take on a value between mu minus 2 sigma and mu plus 2 sigma. Finally, you need to know this. You need to know that 3 standard deviations within 3 standard deviations of the mean lies 99.7% of your data. So this here is 99.7% of your data. So that's mu minus 3 sigma, mu plus 3 sigma. 99.7 lies between that interval. So this you just have to memorize. Memorize this. And we say x is normal with a mean mu and a variance of sigma squared, because the square root of that is your standard deviation. That's how we state that x is a continuous random variable that is normal, that follows this probability density function. That looks terrifying. You don't even have to know that, barely. This is what you need to memorize. And I'm going to show you how to apply it here. So this is what you really need to know. So let's do a few questions. I'm going to clear this. Let's have a look at these questions here. So we have draw graphs for the following distributions. So we know that x is normal with a mean of 0 and a variance of 1. So let's call this example 1. So it just wants a rough sketch. It has a mean of 0 and a variance of 1. So it's going to look something like this. It's going to be a bell shape because it's Gaussian. It's normal. Like that. Okay, and the mean, mu, equals 0. The standard deviation is the square root of 1, which is 1. And this is 0 here. This is our mean. And we can say that around here, that's about -1. It's about +1. That looks about 68%. Just wants a rough approximation. That's about -2, 2. That's -3, 3 there. That's all it's wanting there. A sketch of that. Okay, so let's sketch x, which is normally distributed with a mean of 20 and a variance of 25. So let's see, let's extract the information we need. The mean is 20 and our standard deviation is the square root of 25, which is 5. Let's sketch this. I'm going to use my ruler. I'm going to set a good example. Should be using my ruler. Got one for a reason. Let's sketch this one. Okay, so that's our x-axis. We don't care about y, it's not important. Let's draw our bell-shaped curve. Just drawing any bell shape here. And our mean is 20 and our standard deviation is 5, so it's going to be about 25 there. It's going to be about 15 there. It's going to be about 10 there. It's going to be about 20 there. Whoops, not 20, about 30 there. It's going to be about 35. It's going to be about 5. So it should be symmetrical about the mean. So that's example 2. I'll leave example 3 to you. Whoops. I'll leave example 3 to you. I think you should be able to have a crack at that. Let's have a look at this next problem. So let's call this example 4. A random variable x is normally distributed. It's normal with a mean of 30 and a standard deviation of 5. Find the percentage values which are above 35. Let's do a quick sketch to help us. So let's do a quick sketch of our Gaussian distribution. There, I said it. I knew I was going to say it. There's our bell curve. Okay, so our mean is 30 and we want 35's about there, 25's about there, that's about 20, that's about 15, it's about 40, it's 45. Okay, so find the percentage of values which are above 35. So we want the percentage of values that are above here. Well, we know that 68% lies within this part here. Whoops, so this is going to be about 34%. So that's going to be approximately 34%. And we know this is symmetrical. So we know here is 50% to the right of the mean. So above 35, that's going to be 50 minus 34. That's going to be 16%. So 16% of your data set, 16% of your values will be above 35 here. So you can see what happened there. I said that within one standard deviation is about 68%. So half of that is 34%. Then I'll minus that off 50%. Okay, let's have a look at part B. So above 40. Okay, well, how are we going to do that? How are we going to find what goes above 40? Well, let's see. So that's 2 standard deviations. So we know that. Yeah, it's up to you how you do this. I'll draw it. I'm thinking of the best way to show you how to get it above 40. I'll do another sketch just to make it really clear for each one. I'll do another sketch for B. We'll do it up here. So this is for B. So I want to know how many values are above 40. So we know that 30's there, 35's here, 40's here, 45's here, 25, 20, 15. Okay, so this is one standard deviation. So above 40 is 2 standard deviations. So, well, let's look at 2 standard deviations, right? This is 97%. This is approximately 97%. If that's 97%, then what's left here and here is approximately 3%. So, but we just want above 40, so we just want here, so that's half of 3%, so that's about 1.5%. So the answer there is 1.5%. Alright, how do we do above 45? It's the same sort of reasoning. I'll do another picture. So I think the sketches kind of help with the reasoning. Okay, bell curve. Kind of like I imagine a ghost sort of thing when I do a bell curve. Okay, 45. So we've got 30 as our mean, 35, 25, 20, 15, 25, 35, 40, 45. Right. So we want above 45. Well, we know that from here to here, that's approximately 99.7%. So from here to here, that's approximately 0.3%, but we only want half of that because we want to be above 45. So that's approximately 0.15%. So that implies there we have 0.15%. Okay, I hope that helps with normal distributions. Don't freak out over this. Make sure you can sketch a normal distribution and find these percentages over these intervals. This is the important bit. And if you have been, thanks for watching.